In this video lesson, we're going to look at the formation of covalent bonds and how we can predict the shapes and sort of orientation of the molecules that form covalent bonds and how to show that correctly. So you'll see on your page, you've got a few steps to follow. And so first of all, step number 1 is to draw the Lewis dot diagram for each neutral atom. So in this case, we're starting off with water, H2O. The formula is going to tell me how many of each atom I need to draw. So I need to draw 2 hydrogens and 1 oxygen. So hydrogen, Lewis dot diagram shows only the valence electrons. So hydrogen is in group number 1. It only has 1 valence electron, so I'm drawing 2 of those, and I need 1 oxygen. Oxygen is in group 6, and it has 6 valence electrons. That looks like that. So once we've done that, next we're going to look at the overall charge of the molecule and see if there's anything we need to add, any electrons we need to add or remove. In this case, we're starting off with all neutral compounds, so there won't be any adding or subtracting of electrons. But when we look at polyatomic ions, we will see that they're charged, so we'll need to add or remove electrons at that point. Okay, step number 3 is to match up the single electrons. Okay, and generally you have a central atom. The central atom that you're trying to attach everything to is the atom that can form the most bonds. So in this case, hydrogen only has 1 unpaired electron, so it can only form 1 bond. Oxygen has 2 unpaired electrons, so it can form 2 bonds. So it's going to be the middle, and we're going to try and attach everything to that. So we show how we are going to show the sharing of electrons by kind of circling the 2 electrons together that are going to get paired up. So last time when we were showing the transfer of electrons, we used an arrow to show that they were being given from one atom to another. In this case, they're being shared, so we're just kind of pair them up. Either you can draw a line attaching the 2, or you can circle them. Next, we're going to redraw. So we're going to draw the Lewis dot diagram for the molecule and identify the lone pairs and the bonding pairs to compare. So now we've got our oxygen has 2 lone pairs, which are those 2, and then we're going to see a bond, so a pair that's shared between hydrogen and oxygen, okay, which are these 2 here. So I'll highlight those in orange so we can see that that's those paired. Each line written in a Lewis dot diagram of a molecule represents 2 electrons. Okay, so why don't we even write that? 1 line or 1 dash in a Lewis diagram is equal to 2 electrons shared between 2 atoms, okay, that are on either side of the line. So in this case, these orange ones are our bonding pairs. So we'll do a little color-coded chart here. The orange are the bonding pairs of electrons. And I'll use green to identify these ones as the lone pairs. So they're pairs of electrons that are not shared between 2 atoms. Let's do another one for practice. We've got carbon dioxide. So again, go through the steps. Step number 1, draw the Lewis dot diagram for each atom. Here we have 1 carbon and 2 oxygens. So I need to draw the Lewis dot diagram for 1 carbon. Carbon is pretty much always in its excited state, so you can spread out the electrons like that. and 2 oxygens. So we just talked about oxygen having 6 valence electrons. So there's one. And I know what the molecule looks like, so I'm gonna kind of move the oxygens one on either side just to make it nice and neat to show. But it doesn't matter if this step looks a little messy, as long as it's clear enough to see. Okay, determine the overall charge of the molecule. This molecule is neutral, so we're not adding or losing any electrons like we would is if it contained a polyatomic ion. Step 3, match up the single electrons. Remember that whichever thing can form the most bonds is probably going to be in the middle. So carbon has 4 unpaired electrons, which means it can make 4 bonds. Oxygen has 2 unpaired electrons, so each oxygen can make 2 bonds. So I'm going to start to pair up these unpaired electrons. To be shared between the carbon and the oxygen. So now I'm going to draw this out, a carbon in the middle, and I have 2 sets of shared electrons or bonding pairs between the carbon and the oxygen. So I'm going to draw that out as 2 lines between the carbon and the oxygen, but I mustn't forget these lone pairs that are on the outside. So I'm going to put 1, 2, 3, 4. And you'll notice I've shifted them around a little bit just to evenly somewhat spread them out opposite to the double bond to the carbon. So we've got another double bond over to this oxygen, and again adding in those lone pairs. Labeling, okay, these double bonds, these dashes, are our bonding pairs. And the ones that we write as dots that are kind of on the outside of each of the oxygens are the lone pairs. They cannot form bonds with things. And that would be what a carbon dioxide molecule would look like.